Hey, everybody, welcome to another episode of Block by Block by the Indexing Co. and the Neighborhoods. I'm Dennis. You know me from Twitter as Aperture, and I'm head of research at the Indexing Company. In this episode, my guest is Nicky from Pelagos. She is the CBO and also co-founder. Um, Maybe just kick it off with a little intro, Nicky. How did you end up with Pelagos, and like, what's your experience in crypto?
Sure, with the greatest pleasure. My name is Nicky. I'm based in Switzerland. I've been in space since 2017. Generally speaking, how I end up in space is thanks to the ICO boom. Maybe not so popular anymore, but back then I was pretty excited that you could actually go and participate in the projects, like by just like if you see something that you like, you read the white paper, and you can just like join the communities, Telegram accounts, and kind of start questioning, asking questions directly to the founders, and you could participate actually in investing in them, no matter how dodgy it sounds now. But that's basically how I found space exciting. And then I decided to join it full time in 2017, started my career in a crypto exchange, then worked for the likes of crypto custody solution provider, where I actually worked mostly with the institutional. So it was like crypto on the institutional front. And then I worked with the likes of Neon, Tulsa, and Tyco. And how I ended up in Pelagos is fairly simple. Generally speaking, I've known the folks or my co-founders that have been building Pelagos for quite some time. And I remember like we were discussing back then, like a year ago or so, like the ideas around it. And then they were like, oh, okay, we're going on DevNet. And I was like, okay, maybe guys, you should go like on DevNet, get some like, I don't know, stability, get like certain numbers around that we can show later. And then like we can have a look into it down the road and see what's the interest, what's the market, and so on. And essentially, that's basically what they did. They also secured, I remember back then, the grant from Ethereum Foundation, infrastructure grant. And essentially, at one point, we're like, okay, we're ready to take the project further. Let's just, get together and push it further. Let's get funding and actually roll it out. And essentially, that's what we did. Currently, we're in the phase that we're rolling out our permission testnet. So it should happen today or tomorrow, and we'll be announcing that as well. And and we're onboarding a bunch of dApps to build on our testnet as well. There are certain of them, so certain amount already has built, like the likes of liquid markets. They built the unified order book on Pelagos. Then we have the layer cover, which built the insurance layer. And then we have the likes of Predicted that are building the resolution marketplace. So we do have certain use cases happening already on Pelagos. So that's about my journey and how I end up actually at Pelagos.
Nice. Yeah, we'll dig into these use cases a bit later too, because we want to hear more on the specifics and how Pelagos actually enables those specific use cases and the product. But yeah, luckily we've gotten past the ICO phase and things are actually being built and not just money raised on a pitch deck. So good to hear that you're moving towards testnet. I think when this recording goes live, that's when testnet is open. So if you're listening and are interested in playing around with it, we'll probably link it in the description, so you can check it out. So maybe let's start at just the start what Pelagos actually is and how it technically works.
Mm-hmm. Sure. For that to start, I'll just like walk you through basically the problems in the space. So that will give you a better like idea also for the audience as well. So generally speaking, like if you will look into the space, I mean, we've all been in the space for a long time and we've tried like different chains. We try to communicate between the different chains, and mostly like a lot of it goes via the bridges, cross-chain messaging protocols, or intent and solvers. And I like what you see in the space is like everyone's trying to repair the cross-chain by building better bridges, better intent frameworks, smarter routers, and so on. But in practice, like what you see is like nearly every cross-chain action is kind of a pile of separate attempts and guesses. So, and Kind of, we are calling it normal, and it's not, and we don't believe that it will scale. Cross-chain, we do believe that doesn't need a better route. It needs a single global decision, like where you decide once. Then either everything happens exactly as planned or nothing happens at all. So essentially, that's what Pelagos does. So it's the execution layer for crypto. You sign once. Pelagos simulates the entire path across chains, including prices, liquidity, gas, timing, and policy. And if every leg fits the constraints, Pelagos signs the native transactions on each chain and releases them together. So, and if any leg in some time fails the check, nothing is broadcast. So we do believe that the solution wins for several reasons, because the fragmentation is permanent. Liquidity has chosen many chains, and we don't believe that it will reconverge. In fact, we do believe that there will be more and more chains. Maybe unlike the general purpose chains, there will be more of the purpose-specific chains. Any system must coordinate across them without relying on luck. Also, automation is rising. Agent strategies and institutional systems, they do require deterministic outcomes. They cannot babysit refunds or chase stock legs. But also, we like to talk about institutionals in the space, but we don't really go into the depths of what they need, their requirements, and they are very adamant on the stuff like KYC, KYB, geofencing, limits that must be enforced before the signatures, not after the fact. So basically, what Pelagos is an atomic cross-chain execution layer, and we do accept them. It accepts the market as it is, which is messy and multi-chain, and it makes it safe to act. So our breakthrough is not just another bridge, it's not just another intent framework or whatever, or it's not just another account abstraction tool. It's the atomic decision in front of everything.
Yeah, and I think that's what I like about this model. A lot of cross-chain tooling needs specific features and then only works even on certain chains. But I think with this model, you accept the chain as it is. And I think with that, you actually also start having an opinion on, okay, which chain for what purpose, and then actually the builder can pick that out from your framework. I think what we'll probably see, I'm guessing here, is some applications will start doing using some certain chains. Maybe that's a general purpose or specific purpose chains. But through Pelagos, we'll see that better because it executes there, and you see actually those flows going there because it takes a chain agnostic view. One question then is how do these flows actually work? You mentioned these are atomic. Could you get us from maybe a user intent to do an action
Sure.
from totally something confirming on chain or confirming on multiple chains?
Of course, absolutely. So basically, some of the examples, there are a bunch of them, but I will do for example, the easy ones. So for example, you have your bonk on Solana. You say, I want to swap my bonk on Solana to USDC on Ethereum. And also you want to take that USDC and lend it on Aave on Arbitrum because you have certain opportunity there, let's say, right? And essentially, as a user, you just set what you want with one signature, and that's it. You don't have to, there's no hopping apps, no manual bridging, nothing happens. And then what happens is that Pelagos checks. There's a simulation which is happening in the background, and can this be done right now without going over certain limits? Certain limits can be gas prices, slippage, or whatever you name it, right? Or in case of if we're talking about institutions, those can be certain policies and so on. And then you can also decide you can keep this transaction hidden as well. It's revealed only at the moment it runs, so nobody can front run it. And basically, the idea of the solution of Pelagos is everything happens together, all together or not at all. So you have if every piece can happen, everything fires together. If one piece can't, nothing moves. So you don't get this a half-done mess or stranded funds on Pelagos. So essentially, what you end up with with one transaction, you have your Bonk on Solana sold, your USDC on Ethereum arrived, and you have your USDC actually moved to Arbitrum and supplied in Aave. So like whatever you wanted to get in, and it's all done in milliseconds, which is very important. The other thing is like, for example, let's say you want to move the amounts in one click. You say, I want to trade on Unichain, but my funds are sitting, let's say, on the likes of ZK Sync. Should be possible in one click. So Pelagos moves the first and executes the trade, again in like milliseconds. Or for example, another good instance where we have where all of us, we have our funds everywhere. Like you have your staking rewards on one chain, your incentives on another, your dust somewhere else, and you want to move it to Ethereum in one click. So you claim balances on all chains, you swap. So like you basically ask send a transaction, like you want to move everything to Ethereum in one click. And then the system claims the balances on all chains, swaps them, sends them to destination chain. Or another one, which is basically what one of our ecosystem projects is building, like which is the CLOP, where you can say like, okay, I want to long one BTC on Aptos, my funds are on Solana, it's just a matter of one click. So it moves the needed margin, places the order on Aptos, and settles fees and P&L to the chosen chain. So the message is like, okay, there's many chains, there's one action, and basically the idea is that if it can all happen, it does. If not, something doesn't happen, it doesn't. So basically, like you can have as many cross-chain actions as you'd like.
Yeah, and I think the key part here is that you're doing the simulations, right? Like the simulations happen really quick to ensure, hey, this is a valid path. These are valid actions that can be triggered. How do these simulations take place, and how do you ensure correctness? Is it like validators first simulating and then executing that if all conditions are met? Or how does that validator network basically push these transactions through all these chains?
Sure. So generally speaking, how it works, I can explain it briefly as well. So essentially, yes, correct. There's a simulation. Simulation is done in parallel, and it is to showcase basically that that all the limits and whatever is respected. So I can walk you through maybe a little bit technical, but how the execution works is like we have leaderless DAC, which is the consensus mechanism, which basically makes us somewhat a chain, but we like to claim ourselves to be the execution layer, because in the end of the day, the end user should not even know about Pelagos. And you have like the sequencing, which gives you the instant finality. Then you have reactive multi-chain input and output. So you have like, you basically are able to consume finalized blocks and events and consign outbound transaction using TSS, which is very important. So like TSS is one of the features of the solution. And then you have the concept of dockerized app chains. When we're talking about app chains, it's not like something that you would think of like Dimension or some other solutions, similar solutions. In our case, dockerized app chains, those are the programs that are shipped as images. So the validators, they pull it, they scale it, they upgrade it, and so on. And you can have several app chains running side by side. Actually, when you think of app chains on Pelagos, you should think of actually microservices. So you should have this like kind of this Web 2 analogy. And basically, you are your own execution environment, which means that your solution doesn't live inside someone else's VM. You are like your own state machine, which means that you can actually define your logic and how you want to like do stuff. And when it comes to the state engine, you have like the immutable snapshots and the deterministic sync, which is very important. So how does the transaction lifecycle work is that you have an order signed on any connected chain. The system observes and ingests blocks events into the DAC, which is the consensus mechanism. And then there's a simulation and sequencing, which is second sequencing with instant finality. And then there's a threshold signature, which assembles the proofs. And then there's a commit, which provides you with the atomic commit. So if everything is fine, it finalizes. If one thing doesn't happen, it reverts. And then when it comes to the multi-chain read and write, you have like, when it comes to the read part, you subscribe actually to finalized headers blocks. You have Merkle verified logs, you have account storage reads. When it comes to the write part, you have fabric level TSS, which generates native outbound transactions. So if a leg, for example, exceeds latency budget, it reroutes or reverts atomically. So this is basically more or less the architecture. And on the security layer, you have certain cryptographic guarantees for cross-chain operations. On the liveness layer, you have, of course, like a continuous operation under adverse conditions. And then on the cross-chain sequencing layer, you have all the ordered transaction and L1 events. And the app chain layer consists of the execution, RPC, state management. So this is in a nutshell the description of the system and how each part takes care of different parts. Let me put it this way, yes.
Yeah, and it makes sense that you're calling them app chains because it's all these like small apps with instructions to process that data, ingest that data, and trigger actions. But it isn't a continuous app chain. Like I think that's one of the things we see in app chains is like there's a lot of like empty blocks if there's no user action happening. I think you revert that around where you're saying like, hey, we just only execute when there is a user or a condition being met. And I think that's why you say like, hey, a server can have like multiple apps on there to trigger, right?
Yeah, you can have multiple app chains running side by side. So the idea is very simple, right? Because like in the end of the day, how do we, because there's no solution that will be solving or addressing the liquidity fragmentation as it is. What you can do is like enable that this surface is treated as one single like pool, right? And essentially like what's very important for that to happen, you want to ensure that liquidity can move seamlessly, users can move seamlessly, the cross contract calls can happen seamlessly. So for example, one of the cases will always get asked when we talk to different solutions in the space, like to DeFi dApps, essentially, like, okay, especially the DEX or whatever, but just like, let's take the example of Texas because these are the easier ones to kind of propagate and understand, is that like, okay, if I'm going to deploy my solution on Pelagos, how am I going to attract the liquidity? Because that's actually a burning, I would say, question for many builders. And, there's always like, I don't know, hunt for liquidity, and it's such a merciless job, I would say, an ungrateful job, because in the end of the day, it's like you're actually renting liquidity. So like over time, if you look at it, and you're paying for that rent. And essentially, like that's basically where Pelagos advantages are, because as an app chain, let's say you deploy your solution, you're not deploying any pools on Pelagos. Your core pools remain on the other chains like Bitbase, ZK Sync, I don't know, Solana, whatever, you name it. And Pelagos app chains, they just watch those pools via finalized snapshots, so you get live on-chain reserve data without moving a single token. So a user swap request hits the Pelagos app chain, goes to the routing logic, which is inside the container. It sees like the best quote across all external pools, and Pelagos emits the required transaction back to each host chain in one atomic flow. So you don't have this like, internal pool, which means that you don't need to bootstrap the liquidity, and you can actually already leverage the battle-tested liquidity you already have, especially this applies for bigger projects like the ones that have a higher TVL. Like you never need to maintain like, let's say your own token bridge or paid to seed liquidity on the app chain. Like basically Pelagos handles all the TSS signing and broadcasting. So your only task is like to listen to your pools and route trades and sign and enjoy the settlement guarantees. So basically this is, for example, one of the example of the DEXs, how it works with the like liquidity on the DEXs, right? And also, like one thing that I would like to mention, because we do get that a lot, maybe it's a little bit out of the scope of the question, but still I would like to address that.
Go ahead.
Because like, we do get compared to a lot of intent-based systems. And I would like to also emphasize that intent-based systems and atomic execution frameworks, they're a bit different. So the distinction isn't just like academic one. For builders like building the next generation of dApps protocols, the choice between intent and atomicity actually determines everything from user experience to risk management, but also from capital efficiency to composability, right? So what is the intent-based system? Intent-based systems operate on a marketplace model. So users express their desired outcomes, like let's say I want to swap this to that at the best price. And a network of solvers, feelers, or relayers, they actually compete to kind of like find and fulfill this request. The intent gets broadcast and solvers start to submit like their bids or solutions, and eventually one executes the user request. And yes, this approach is quite like nice and offers some flexibility because it can aggregate liquidity across multiple sources. However, it does introduce limitation because in the end of the day, if you look at the intents, they operate on best effort execution. Like, while like if you look at the sophisticated matching algorithm and other systems, they improve success rates. Like they cannot actually guarantee that there'll be a simultaneous execution across multiple chains. There's an all or nothing settlement for complex operation. There's a deterministic outcomes before execution begins, or there's a protection against partial failures mid-transaction. So like, for example, when a perp dex, let's say, needs to atomically update margin across chain, or a liquidation protocol must ensure, for example, collateral sale and debt repayment happen together, best effort isn't enough, and you will not be able to actually attract institutions with it, right? The atomic execution is different because the atomic system also leverages the threshold signature schemes for native transaction authorization, which is very important because you don't have wrappers, you don't have like a non-native, tokens or so on. You actually are working with the native assets. And you have DAC consensus for instant finality. You have also deterministic sequencing, which is very important because it does ensure the order and causality. And then you do have cryptographic proofs, which has to validate the complete execution. So, for example, if you look at Pelagos, when Pelagos processes a cross-chain swap, the protocol doesn't hope solvers will execute correctly. It actually cryptographically ensures atomic settlement across all involved chains within a single, like, I believe, 400 millisecond block.
Yeah. And it's like the thing I think is possible here with a solver, the intent can only be quite simple because you have all these solvers probably like out competing each other on a single ask, but they still have to agree on like, hey, this is the ask being filled. But the more complex that ask, the more people stop, of course, competing for that process. So in a way, intents work very well with swaps and bridges because it's often a single ask. And what you're basically saying here with the atomic swaps is like you can have multiple asks. You can have more complex layers in your ask, or like thresholds or conditions that should be met to execute them. So maybe a simple example of so let's say I want to do a simple bridge because we're still talking about like swapping, but I just want to move funds from one chain to another. How would that work with Pelagos? Or would you say like, we don't care about that because we see funds on one chain and that is the source of truth anyway. So, and we are a bit like chain agnostic. You just have the funds. How would a flow like that work on Pelagos if I just want to move funds basically from chain to chain?
I mean, generally speaking, right, like, again, what you mentioned about like mirroring what you have on other chains, because in the end of the day, as Pelagos works, it's like we do have access to all the pools and all the information and so on, right? Like, that's the thing. So what do I mean by that? If, for example, the pool is permissioned, you can just slap a UI or whatever app chain you want for whatever you want to do, and then access it if it's permissionless. Sorry. So essentially, like, what do I mean by that? So let's say you want to access the Uniswap pools or whatever, like and you can read and write, because you can just build an app chain on top of Pelagos, and the pools are permissionless. We can do whatever you want in that sense of, let's say, so, and if we're talking about like asking for a transfer, you basically like, what we have in place is the SDK, right? So SDK builds a bundle with all legs. You have the source leg, you have the target leg, and you can also, for example, enable optional swap legs if needed. Pelagos simulates again every leg against live states, so whichever state is there. And basically also you have the liquidity, which on all the other, for example, chains or whatever, so you don't get stranded. And there is like a quote plus pre-commit. I would say you get a quote plus a bundle hash, and you sign that bundle hash, and this fixes the term. So you, for example, execute the source leg on A. So SDK submits, for example, like the single source transaction. If allowance is needed, handled, funds move to a Pelagos adapter, like adapter escrow on chain A, let's say. And the transaction includes your bounds and bundle information. So if anything downstream can't be guaranteed, the whole thing will abort. And then there's a decision, commit, and abort, right? So Pelagos watches, like, let's say, chain A until finality. Validators sequence the bundle in the leaderless tag and run the same simulation snapshot. If all like post conditions they still hold, they commit. So if nothing, like they abort on Pelagos specifically. So, and receipt is that, like, what you get is SDK emits a verifiable receipt. You have your source transaction hash and block and time, for example, and your wallet shows confirmed, for example, USDC on B or wherever your destination was. So when it comes to the, basically, like, that's where we're talking about deterministic outcomes. Is like you have this pre-commit simulation plus liquidity reservation plus and the route that you have, like it can't mutate after you sign, which is very important. So that's basically how it works on a kind of like a easy, like, example basis.
Nice. Yeah, and I think what this enables builders is just like focus on both like execution logic and front ends, without worrying too much about the underlying infra where it happens. It's just like you can do more complex actions across all these chains or single chain, whatever is needed to build your application. So most obviously, like aggregation use cases like DEX aggregators, bridge aggregators, like those come in mind. But I think there's a lot of use cases here that like aren't like top of mind. So what kind of good use cases do you see, or even like what kind of applications are now possible with Pelagos that weren't possible before? What's the big unlock here?
Oh, definitely. So, I mean, actually, we can apply it to a bunch of use cases. So, for example, one of the best use cases would be cross-chain lending. And that's a very important one, because when you are talking about lending has an interest in liquidation. So you enable actually them to liquidate same assets on all chains. So let's say I deposited 100K worth of Ethereum and borrowed 50K USDT. And at one point, let's say the Ethereum price goes down and there's a liquidation event. So you want to get USDT. So as a lending and borrowing protocol, you say like, okay, I have ETH, I want to get out of it, give me USDT, and you have all access to all the USDT on chains. Even bridges, like no other solution can do that at this moment. So that's one thing. The other thing, for example, that's happening on Pelagos, apart from unified order book, and as you mentioned, the aggregated aggregated DEXs and so on. We do have, for example, a resolution marketplace that's being built, which is they are basically delivering an event query dashboard that external parties can treat as a source of truth. So basically how it works is that partners can interact with predicted contracts in an Oracle-style pattern to resolve prediction events. And while predicted uses a simplified resolution method, building on Pelagos preserves transparency and propagates validated outcomes to any connected network that requires resolution services. And the other one, pretty cool one, is actual insurance coverage, which is being built by Layer Cover. So they have deployed a dedicated app chain on Pelagos for purchasing insurance policies. So the flow is, for example, like this. Alice buys cover and pays USDC on Polygon. Pelagos attests and confirms the purchase on Ethereum, and the app chain records that Alice bought 1,000 USDC of cover on Polygon, while reserving assets on Ethereum. So result is that you have like native cross-chain policy issuance and reserve accounting without bridges or wrapped assets again. And then the other one, for example, which is my favorite, and I think that will be the how the future will be dictated, or the future of DeFi. It's when we're talking about the agents, agentic DeFi. So generally speaking, yes, you do have several solutions as that, like where basically like you like tell to the agent, okay, like do this, do that, and get me this APR or API that already exists. But when it comes to the like actual, when we're talking about the cross-chain solutions, there are definitely, I would say, shortcomings. So, and essentially like what you can have is that you can have actual solution where you go and tell to the agent, okay, my name is this and that, I have a very conservative risk profile, here's my budget for the next 3 months, please generate for me this much, and please be conservative when choosing which protocols you're using. And the agent then goes and does this for you, right? So you don't have to take care of rebalancing of anything. And essentially, like it does everything, also all the cross-chain actions for you as well. The problem is that if today you do that, it's a little bit, it's a little bit of a, I would say, like a risky way of doing things, because in the end of the day, like if you have to utilize bridges or some other ways of doing cross-chain actions, even enabling the agent to do that, like sometimes your funds get stranded on bridges. Like it happened to me also with very well-known names and so on, and essentially like also like the operation doesn't get fulfilled completely. But here with Pelagos, you will not have that bridge interaction as an agent. So also like you will generate higher return, because in the end of the day, you will not incur those bridge fees. That's another thing. And essentially, like you will be able to kind of allocate and rebalance across chains in a much more easier and seamless manner. So this is another use case, for example, what you can do. And there are a bunch of them. For example, you can build order resolver agent, where you have like you can consume user transactions and return and plan and quote. You can also package your strategy into app chain with fee sharing, and users can hit your API and you can monetize. You can basically like do a bunch of things. You can have like, for example, cross-chain liquidation agents as well, detect like, for example, under collateralized positions on a specific chain, borrow on another chain, and repay on chain A, and so on. And like the other one that I would like to also pinpoint is the institutional, I would say, use case, because in the end of the day, what Pelagos enables, like to have, is permission compliant app chains without like the need to, like you can have a regulatory setup without the need to sacrifice performance, with atomic access to public chains if needed. So that's some of the examples.
Yeah, well, those are great use cases, especially the agents one, where I think that's very limited with agents. We expect these agents to be able to do everything, but in the end, it's just the builder itself that that defines like what the environment is the agent can work in, which is very just limited to how much integrations a builder can do. It's mostly only a single chain or the few chains a builder supports, so that agent will always be limited, while a user, actually wants to use an agent to be able to do all these different tasks for them. I think you're flipping that around where you say like, hey, this agent now has a execution framework, and that framework can tap into anything, which then unlocks a lot of possibilities here. That maybe begs the question about like how is Pelagos integrating like new chains, or is that like community led, like builders can just do it themselves and use Pelagos, or is that more from like the Pelagos level where you have to onboard like new chains to make this possible?
Sure. I mean, at the moment, like as long it's on the protocol level, so we have to do the work ourselves. Generally speaking, for EVM chains, it's pretty simple. We get to do it in a very short period of time, and we're also supporting Bitcoin. It took some time for us to actually enable Solana, but I would say sometimes like 2-3 weeks, not something extremely crazy. I would say from that perspective, like to enable read and write. But in the end of the day, like it depends. If there are specific use cases that do require specific chains, we can enable them without any issue. And we do enable them. So if someone says like, oh, okay, I need Base, I need that, we get this set up in no time. Again, it really depends on the use case. So far, like, to be honest, we would love to enable all the chains, whatever is out there, even smaller chains, bigger chains, as long as there are different use cases and there's a need to tap into those chains. Why not? I think like in the end of the day, all of that should be there.
Yeah, and it's of course up to like the protocol level to just enable the builders what they want to build. So in the end, it is always like on request and like builder focused, but at least you want to integrate something that's being used and not just like endlessly integrate everything. And yeah, that will just keep you stuck at a protocol level. So what, like you mentioned, like testnet is going live. What's the plan for the testnet? Like, there's probably phases in that testnet that gets you towards mainnet. How does testnet look like, and what steps will it go through to get like to official mainnet and official launch?
Sure. So I can give you a little bit of an overview of our roadmap. So at this moment of this testnet, so we're gonna actually do certain, I would say, campaigns for the dApps that have already deployed on Pelagos testnet. So we will have actually the campaigns for the users to do stuff, for the users to come and test, like for the community, I would say, to come and test those dApps and to check how it works, to familiarize themselves, like it's easier. Like I think when you see how it works, it's much harder to explain it than to actually go and play around with it. So and we do already have certain like videos that we showcase, like for example, we have showcased how unified order book on Pelagos works with liquid markets, and soon we'll be releasing the video of insurance coverage protocol as well, so like people can see it. But that's the idea. That will be the next step for the testnet, the imminent next step for the testnet, I would say. But then like also, what are the next steps, right? So there are several, as you mentioned, there are several stages of testnet. So we have to have the TSS integrated with GG20 and FOST. Then we'll need the block explorer built, validator deployment framework as well. Also, we'll need to have the infrastructure audit, which will be the first one for clashing and recovery flows, and then for scaling and load testing. And then we'll have the staging testnet, where we will have to start audits for TSS, Solidity general, and we'll have to also have check for the P2P replacement, Rust consensus, and GraphQL upchain. And then in Q2 2026, I believe we will have the infra audit too, where we will have the consensus audit, TSS upchain audit, and we will release our Rust SDK. Also, we will apply the fixes across stack post audits for to have this readiness for mainnet. And Q3 we do aim to go on mainnet. We will have certain, of course, buffer reserved for slips. And we'll have the partner migrations and essentially the GTM, like going to market, like with the dApps, with the token and so on. But I would say like a next step would be to kind of build a framework for validators and to start onboarding them, to start at least like during the phases of testnet, we will be onboarding validators in a permissioned manner. So like basically we'll be checking with who we're going to work. And then when we go to mainnet, we will make it permissionless. So that's the idea.
Yeah, wow, that's a lot to do, but it's also good you're already having like builders building on top to have the actual use cases to see what you're running into. I think that's always best if you have like people external and actually building real use cases on top to verify the direction you're going and basically do these audits also with their tech. So I think you're still looking for also more builders to be part of this testnet, right? Like what kind of builders are you looking for? Like the validators are permissions, but for builders themselves, do you also permission that, or can they just like contact you?
They can just reach out to us and we onboard them. So, I mean, to be precise, like we are looking for different use cases and we are happy to support and actual handhold. And that's what we're doing currently as well with the set of builders. Generally speaking, like for the builders, it has been a pretty seamless, process of deployment on Pelagos, because even though we are just going to the first phase of our testnet, we were on DevNet before, and still it was pretty clear, pretty nice. It didn't take more than a day for them to deploy. But in the end of the day, we also have to work with them closely and take their requirements also into account, because like we need to understand, okay, what do they want to build, what does that require, like how we can enable it much faster and so on. So we need to also like kind of congregate and collect that feedback, and essentially that takes a lot of time, I would say, on our end, and actually like supporting all those guys. So I would say like that takes quite some time from us, also like from the other efforts as well, but nevertheless we do that. And if there are interesting use cases, people building cool cases like on DeFi side and so on, and would like to explore how it works on Pelagos, would be more than happy to support them and to help them out. And they can reach us, like they can ping us, and would be more than happy to explore how to work. But generally speaking, yes, so far it's like that. And we do have certain also things on our roadmap that we still need to enable from the DAO perspective, like DA integration perspective. We want to integrate a couple of DAs where we'll be enabled to work on the institutional use cases as well. So that's the idea, yeah.
Awesome. Yeah. So yeah, if you're working and listening to this podcast, I want to help integrating the A layers. I hope always that there is some builder that will listen to this podcast like, oh, this is the project I want to work with or work on. So reach out to Nicky. What's something we have missed so far in this conversation that you definitely want to tap into still, and want to have out there?
Sure. I mean, I just, generally speaking, I can tell you like basically like what our thesis is, because as I said, right, we do get, like some of the questions we do get asked, like, are you guys an intent framework? Are you guys, do you guys use a bridge in the background? And so on, like, can I do something on Pelagos? Can I build something on Pelagos? Yes, of course you can. And from that perspective, yes, Pelagos is kind of an infrastructure, but it's not the type of infrastructure that you would say like, okay, how do I resolve my cold start problem? How do I attract TVL to my whatever project, which is built on this chain or whatever? No, that's not the case, because in the end of the day, the goal of Pelagos to make things seamless and much easier. Like in our end, like the end user shouldn't even know what Pelagos is. So that's how it should work. That's what we call seamless. And essentially, like how I would define Pelagos, it's like it creates a singularity the multi-chain space lacked. So you have one decision, one event horizon, and native transactions everywhere or nothing. So kind of Pelagos eliminates this idea of bridges, of messaging, and solver intent layers for anything that moves the value. So it's not passing messaging or minting wrappers, it executes. So you sign once and it simulates the whole thing. So, and also if, for example, sometimes we do get compared to other, let's say, solutions like superchains, like OP Stack and so on. Superchains, what they do, they stitch rollups together, but each rollup is still a separate pool, like gas token, like mempool or a failure surface. So, and Pelagos makes the whole approach like optional for value moving flows, keep the app where it lives, hit liquidity anywhere. So you can have your app where it wants to live, that's the difference. And you can hit the liquidity anywhere. We're not saying like you should be deployed on this chain or that chain. So that's the major, I would say, differentiation. And that's something like we would like to convey and for the people to understand what's the value of Pelagos in general.
Yeah, and I totally get that. There's a lot of solutions that just take the symptoms of like the underlying problems and then fix that with another solution on top. But I think what you're doing is just like take the tech as it is and like see the liquidity where it is and see the activity where it is and just provide a good tool that can execute all of that cross chain. So I think that's why like also I was very interested in having you here because that aligns quite well what we're doing like in Mexico in the neighborhoods where we just say like, yeah, the data lives where it lives, like on these chains and certain databases. We just want to make it accessible, like, and where we're like the data read layer and giving that to builders, you're providing those builders with like an execution layer. You know, the tech is everywhere. With us, you can now execute everywhere you want in the most ideal fashion. So, yeah, I think that is actually a very good conclusion to this episode. So maybe for the builders or community members listening, what's the best way to find you? Like, what's your Twitter, and what's the best way to stay in touch with Pelagos?
Oh, sure. So you can actually, guys, go on pelagos.network and check our website. Then we do have also our X account there and everything. But generally speaking, or you can reach out to me directly if anything Pelagos related. You can just like reach out to me on Telegram. It's at Nicky Chalabi. So altogether, feel free to reach out. And if you want to, like, you can reach out also to me on X. So I check my DMs all the time. Don't worry. If you want to build or explore something on Pelagos. Or generally speaking, you can reach out also to Pelagos account on X as well. We check that all the time as well. And yeah, if you have any questions or anything you would like to ask or whatever, like you're interested, you're curious about it, or you would like to kind of explore how to build on Pelagos, please do. We'll be more than happy to help you. So generally speaking, we're very responsive. So we're trying our best.
That's what I've seen too. So yeah, good to hear. I'll leave some of the links in the description of this episode. Thank you, Nicky, for hopping on this recording with me. Good luck going to testnets with Pelagos, and hope to see you next time.
Sounds good. Thank you so much. It was awesome speaking to you, and really happy to be here. And yeah, thank you so much once more.
Cool. Thank you.
Bye.